Yeah, I think we can start. Yeah. So yeah, before going on to the next class today, any doubts in the deployments, anything? Yeah. So today, I think so far we have seen how to create pods. What are different resources to create pods in Kubernetes, right? We have seen pods, I mean, not general pods. We have seen replication controllers, replica set, and we have seen what is that? Deployments also. These are all to create pods with different advantages for each and every of its thing. Today also we will see how to create pods only. There are a few more resources to create pods. So we'll see that today. The first one is DaemonSet. DaemonSet. This is one of the resource to create pods. Let's see how it works. What is the advantage of this, and why we use it. So the main agenda is to create pods. Obviously, it'll do it. That's what I mentioned. But why? I mean, why we need to use DaemonSet, and what advantage that it will bring to us. That we'll see today. Let's say, let's take an example. You have mm, some agent. The agent with which usually let's say monitoring agent or something, or logging agent. So these kind of agents, you just need to define only once in a system. Let's say I have an agent. Let's say let's example let's say this one. What is that? Any tool, any service. Let's say there is a service. What the service will do is the service will usually talk to my my system and gather the information about my system. So any service, let's example as a service. So now what happens is so this kind of service is required only once, right? We just need to install one time. We just need to run the service one time. You don't need to, let's say Nginx is there as an example, just as an example. Maybe not a good example, but as an example, let's say you just need to install Nginx once, right? You can configure anything, or Apache once, or Tomcat once, not twice, in the machine. Let's say you have another machine, so you have to install there. It means these kind of services required to run only one in each and every machine. So usually we can run multiple ingresses, Nginx, so there is no issue with that. We can change the port numbers, but what I'm trying to say is let's say you have a scenario where you need to run one pod in each and every node of the cluster. Let's say I have how many? I have I think two nodes. So I want to run my pod, one pod in each node. It means one in this node, one in this node. So I want to run two. So at that time we'll be using daemon set. Do you remember in Docker Swarm we have a global mode? It will just run the pods based on nodes only, one for each node. Similar here also daemon set. But what is the use of this? Why we need it is this will be useful mostly for any kind of monitoring agents or any kind of networking components or any kind of uh, logging agents. As an example, we have one thing. Let me show you. This N, what is this N? I haven't told you yet. That will come. Don't worry. Sorry. So this core DNS pod is as an example. Let me just 1 minute. There should be another. Oh yeah, Calico here. Let me use this Calico. Let's say these things. This will run only one time in each node because we don't need to. This is a networking component, right? I told you CNI container network interface, which is required to get the communication between nodes and master. So this is required. So only one time is enough for this. Why we need two networking components in one system? It's not required. Just one is required, right? So this is one of the scenario example I meant to say. So like this, if any scenario, let's say you want to run a pod, only one pod in each and every node, at the time you'll use this daemon set. So this daemon set runs one pod in each node. It means how many nodes we have? We have two, right? So it means when we create a daemon set, we don't specify anything. I want this many replicas like this. It will automatically figure out, okay, we have this cluster has three nodes or four nodes. We'll run four pods, one in each node. So mostly this daemon set will be used for monitoring agents to run any monitoring agent because these monitoring agent or let's say to gather the logs from the system, one agent is required for system or server, two are not required. So at that time we'll be using this daemon set, not for regular applications. Let's say I want to deploy my application, general application, which is running in Tomcat. With the daemon set, you can run it, no problem. But there is no scaling. There is no scaling. So it will run. Currently here two are there. It means only two will run. So if you want to increase the count, you can't. You can't. You want to increase the pods, you can't. If you want to decrease, you can't. So like that. So this will be only useful like when these kind of monitoring agents you need. So at the time you will be using daemon set. Anything, I mean anything which required like this. So how we create it? Same thing as I told you, right? Same template. We'll change a little bit, based on our requirement. So now today we'll do is like, like 1 minute, sorry. So yeah. So how we doing? We'll write a manifest file and we'll be creating the daemon set. Let's copy this cat deploy. Yeah, this is fine. Copy this and go to our YAML link website. YAML link. Yes. It will just validate your YAML file. If you do something wrong in the file syntax, not the whatever you wrote. So this is the file. How you write it? So first thing, kindness. Obviously, you have to change the kind. Daemon set. DAEMONSET. Daemon set. Metadata, of course. Test DS daemon set. I mean, replicas not required. So strategy. These are all for deployments. Remove this. Only this will be there. Spec selector match labels. You can change this if you want. Maybe test DS. I'll just keep it test DS. Template is fine. And as app test DS. Sorry, name. Yeah, my part is fine, completely fine, no issues. App test DS. And these you can change according to your scenario. So now what happens? That's it. I mean, the daemon set configuration file is done. Now what happens is this will create one pod in each node. It means in two nodes are there, it will create two pods. Of course, within the pods, two containers. Obviously, that's what we mentioned. Let's try that. We didn't mention replicas anywhere, right? Let's see. Paste it. Paste syntax ds.ml. Same thing. Kubectl apply icon of ds dot created. Kubectl get po. See, two are running. Did we mention two? No, right? Kubectl get ds. Ds will come. Yeah, ds. It's running currently one only, not two, because the master is blocked. We'll disable that, don't worry. See, how many nodes are there? Two are there. This is master, ignore it. Only one is there, right? And see, the one is running, right? Obviously. These two byte is pods. I mean, the containers inside the pod. I forgot that. Let's try little more details, like -o wide. So what is the IP? 220. See, 220. We didn't mention anywhere. It will just automatically figure out how many nodes are there, and it will run in each and every node. If I add one more node now, it will work. It will it will run in the master also. We just have to disable it. Let me untain it. What is that? Hmm, 1 minute. The node, where is it? Yes. Copy, paste. So here there will be a taint. I have to remove that so that it will allow taints. Unscheduled paths. Okay, it should work then. Okay, it's not working. Right. That's okay. So let me just do it. This daemon set won't run the pods in master nodes because master nodes we have, I told you, right, we are tainted. What we can do is we can, let me change it. Where is the taint? I just showed you. Sorry, yeah, this taint. Taint means just applying a condition here. If we use, I mean, if we want to run in master also, this condition has to be used in the ML file. That's a different topic, but let me show you for now how to use it. You know. Motions, key, node role control flow. Blah, blah. Forget about what I'm writing. I mean, just the condition I'm adding here. So based on the condition, just allowing to run. But this is a separate topic completely. Once topic comes, I'll let you know. I'll tell you fully. Now I'm just trying to show you that the daemon set will run in master also. Valid, it should be here. Control C. Let's copy here. Sorry. Oh, I forgot to delete. Deleted. Now apply again. See, desired 2, current 2, ready 1. It will take time, but don't worry. It will create. kubectl get po c2 running. One in master, one in node. If there are one more node, it will automatically run this daemon set in that node also. If there is one more node, let's say there are 10 nodes, then what daemon set will do is, okay, there are 10 nodes. It will run in all the 10 nodes. One pod in each and every node. It means it will run 10 pods. Exclude master out of it. Unless we add a condition to run in master also, it will run in master. Otherwise, except master, it will run in each and every node. Got it? That's how usually it will run. And again, when this will be useful, we don't use this to deploy our application. Mostly, I'm telling you, right, the agents. any kind of monitoring agents or logging agents or some networking components. Only these scenarios you want it will be using this daemon set. Otherwise, no. Anything you want to run in each and every node with one pod is fine. You can choose this. There is no scaling. You can't, do the scaling here. Of course, you can delete this pod, it will automatically recreate. Let's see. kubectl delete pod slash the pod name. Let's wait. See, it will create. Because even though we didn't specify any number, that's how DaemonSet works. Now there are two nodes, one pod is deleted. I need to think, okay, there are two nodes, but only one pod is running. I have to create that one another pod. Wherever, in whichever the node it is free. See, it's running in two different nodes. Let's say if I delete this pod as an example, it will think, okay, in this node there is no daemon set, pod is running, so let's create in this node. So like that, it will do it. Got it? Is it clear so far?
Yes.
That's what daemon set is about. So that's what is daemon set about. So it will run one pod in each and every node in the cluster, excluding master, unless we add a condition. We add a condition, but that's okay, that's a different topic. Excluding master, it will run in each and every node. Any use case, if you want a scenario, have a scenario like this, you can go for daemon set. But mostly, as I told you, right, only three scenarios so far I've seen. Mostly everyone might have seen the same. Logging agents or monitoring agents, any kind of agents, because one agent is required for the mission. So that's all. That's when we use it. That's called daemon set. So let's delete the daemon set. My resources are very less, so I can't keep it running. Let's clear. So far, like we have seen pod, correct? Replication controller, replica set, deployments, daemon set. So far we have seen this, right? These things. All these are the same purpose, to create the pods. Of course, each and everything have its own advantages and disadvantages. I mean, the features differ based on each resource. These are all Kubernetes resources where we can able to use to create pods. Depends on a requirement, you can use anything. If you want to create a one pod, single pod, no scaling, no health checks, no anything, just run a simple pod, you can use this. If you want to maintain a desired state, use this. If you want to have, you want to deploy your, create pods with maintaining the desired state and with features like rollbacks, recording your deployment history, and as well as strategies you want to make sure there will be less downtime while deploying, you can use go for deployment. And if you want to run the pod in each and every node within the cluster for some reason, as an example I'm saying, you can go for daemon set. These are all to create pods. There is one more thing, the final one, to create pods. StatefulSet. There won't be any space, but yeah, just give it. So this StatefulSet is the final one to create the pods. Let's see what is the StatefulSet and how it is useful. Got it? So this is the last service to create pods. If you observe here, until now we are creating pods only. We are creating pods, we are running them, we are checking them, but I never tried to access the pod, correct? If you observe in the classes, Kubernetes classes, I never opened the, let's say, Tomcat pod I'm running, Nginx pod, but I never opened it in browser. That's when we never did it, right? Don't worry about that. That's a separate topic. I didn't ignore it. It will come.
The
Similar way,
mapping,
similar way. Not exactly, but similar way. We haven't done that yet. It's a separate topic. We'll see on Monday. But for today, let's close StatefulSet. Yeah, that's the final one. creating pods. What is stateful set? Before knowing stateful set, maybe you should know about applications. There are two kinds of applications usually: stateful applications and stateless applications. So, what are the difference between these two? Stateful applications, let's say as an example, as you can see the definition here, it will store the session data on the server. Let's say now I hit google.com as an example. I just open, right? And there will be connection created. The request will go through that connection from my laptop. I mean, I'm the client, obviously, to the server, wherever the website application is running Google. So the connection will open, the request will be sent through the connection. But here, let's say I'm from India, Google is somewhere in California maybe. So I send a request. Stateless application in general scenario, it won't store the information from where I'm coming from. That's what happens usually. So each and every, of course, the connection is open with me and client and server. I mean, me and Google between the servers. So the connection is open. The request, I'm hitting hundreds of requests within the connection. Usually the connection stays for a time period, maybe 30 seconds usually, minimum time until up to 10 minutes maximum. I mean, just as an average. So within the time period, I'll send request, and each and every request will send as a new, because the stateless application don't store my information, session data. Session means if I open a session, it will usually have information about where the request is coming from, where the connection is opened, which country, from the device and everything. But stateless application won't store it. Let's say I want that. I want to store the session data on the server. Why you need to store here is it will be useful for you, in order to process further. It will be useful, like, let's say uh, Google stored my data, I mean session data, as an example. Server stored it. Maybe next time after 10 days, if I, access it again, the information is there, right? My session, my information is there. My information is the request information, not my personal information. Is it present in the servers? So it will immediately, the response will be faster. The processing will be faster. It will like, let's say go to a hotel. If the owner knows you or chef knows you, he'll, make it to you faster, right? Generally, if you go to a new hotel, it will be normal. But if you go continuously, maybe every day or within a week, something like that, he'll identify you. The serving will be faster. Similarly, like this here. Stateless versus stateful. Stateless won't store the session data anywhere in the server usually, and each request will be treated independently because it's not storing the session data. So each and every request, it's independent. But stateful application, it will save the session data on the server, which provide context, that for each and every request, it will know that okay, you are coming from here. Last time you tried this. So the processing, I mean, processing means the accessibility will be faster. So that's why usually these two kind of applications are there. So when to use stateful applications then? Mostly people use stateful applications for databases. Mostly for databases. So MySQL, Postgres, anything, whatever the database is in the market. So we'll be using that. Or we have consumers in between, distributed systems like Redis, Kafka, Cassandra, Zookeeper, multiple queries. So this will sit in front of the database for caching and everything. So for these kind of things. So we'll be using these stateful set. Why I'm telling all this is we have the topic called stateful set. This stateful set, out of all these things which create pods, stateful set is the only one which can handle stateful applications. Means this stateful set can store the session data. Remaining all are stateless. Stateless means it does not store the session data. All these things does not store the session data. Got it? That's the difference between stateless and stateful. And in Kubernetes, stateful set is one of the kind to create pods which stores the session data. Got it? What I'm saying? Is it clear? Any doubts? I mean, in the on what I'm explaining, is it clear or is confusing? All right. I'll. Sorry, yeah, say it.
Yeah.
Yeah.
Okay.
Yeah. Sorry. Yeah. Let's continue. Yeah. So yeah. So that's about stateful application. Not. I mean, it's not. We haven't come to stateful set yet. That's about stateful application and stateless applications. So mostly I told you right for databases, for caching services are there. We'll be using for that because database need session data to store so that the processing will be faster. Then the serving whatever the data is processing will be faster from DB side. That's why it's required. Now coming to Kubernetes, we have something called a stateful set, which does the same task. So when you want to deploy some stateful applications like databases, anything.
Mm,
Sorry, someone,
clear.
please mute yourself if you're not talking to me. Yeah. So if you have a stateful application like databases you want to deploy in Kubernetes cluster, you'll be using this. Of course, you can use any of these, but of course, it does not store the data, session data. There is no point of using this. That's why you'll use stateful set. Usually, there will be a common question asked in interviews like, what is the difference between deployments and stateful set? Very, very common question.
Okay.
Very, very common question generally asked. So let's see what are the differences. I mean, why? First thing, of course, obviously, stateful set will be used for stateful applications where to store the session data, usually, which are required for the application. Deployment for the stateless application. That is obviously first thing. Another thing is the way it creates the parts, that is a little different. Let's say for deployment, let's go to deployment, qctl apply -s deploy. Uh, yeah, but meanwhile, when we do this kubectl apply deployment file, whatever it is, this will create the pods randomly with some random ID, some random names. It's there is no specific thing that it will be generally using. But in deployment, it's not sorry, stateful set, it's not like that. Stateful set create the the pods, sequential manner, one by one. That means, let's say if I tell deployment to create two pods, let's say I told right, cat deploy I told to create two parts, correct? Let's use it here, apply hyphen, let's deploy. It will create, but it's some random, correct? What is it? Oh, no one knows. It's some randomly it will assign some names. There is, I mean, no uniqueness of these parts. It will just create randomly anywhere, wherever it is. It may, these two parts may run in the same node or in a different node, does not really care. But in stateful set, when we create pods with stateful set, each and every pod will have its own unique identity. Unique identity means they are not duplicate of each other. Each and everything have will get a unique name, get a stable host name also. Even if they reschedule, the pods, how the pods will be created, the order wise. Let's say I told to create 10 pods in stateful set. You know what the pod names will be? Pod 1, pod 0, 1, 2, 3, 4, 5, like this will be. That's how it will create, in a unique manner it will create and one by one, like this in a sequential manner usually. That's how usually it will create. That's one of the difference. One is, final agenda is to create pods, but we're discussing it how it creates. That's the difference. One thing is why we use stateful set because we have in a stateful applications which required to store the session data, session information. At the time we'll go for stateful set. The pods will be created here in a sequential manner, with unique, I need a unique name 0, 1, 2, 3 like this. You'll see that, don't worry. And another thing is stable storage. Usually here, these two pods which are created by deployment. obviously. These will share the same storage, a common storage between these two parts. There, we haven't discussed that. I mean, the storage part is completely separate, but just as of now, these two parts which are created by deployment will have the same storage. It will be using the same storage, a common one. But the parts which we create by stateful set, each and every part it has its own storage. Even after deleting the part, let's say in stateful set, the volume will be there. The volume will be present because if the next part is created, it will use that. I mean, it will preserve the data. So now let's say if I these two parts as a scenario created by stateful set. So what happens is this part, let's say part 0, will have its own storage. This part 1 will have its own storage like this. Got it? Even let's say when we scale up the pods, you know how this will create in a sequential manner only. 0, if let's say two parts are running, I want to scale, it will be 0, 1, 2, 0, 1, 1, 2, 3, 0, 1, 2, 3, 4, 4. Like sequentially it will create. And sequentially it will delete also. So it will do like that. But in deployment or any of these things, it's random. So randomly do the scaling, randomly do the deployment, anything. But here it will follow a procedure. That's why stateful set is different. We'll see that, don't worry. Whatever the points I told, we'll see that. Let's write a stateful set. Stateful set also similar kind of thing like this, but a little extra thing. What is the little extra thing I told you, right? What is it? The storage is separate for each and every pod. So that part we'll be writing here. So for now, the storage is not, we haven't discussed it yet, but let's talk about it. I mean, first thing here is this kind stateful set. Got it? Name test SS, maybe even stateful set. Here, spec. In the spec, we'll write the service name. What is the service name? Maybe MySQL. Wait, it's no capitals. And replicas we have to write. Anything. For me, 2 are enough because otherwise my server will go down. Replicas 2. Next, character match labels. These are all fine. Test access. Okay, this is fine. Templates. Name you can remove if you want. Otherwise, no use of this name. Test access. I'm trying to match the same label. I think I already told you this, but let me tell you again. We have to match these two things. Whatever we write in the spec selector and whatever we write in the template. Then only they'll couple together because we are creating some resource, let's say DaemonSet or deployment or schedules, let's say, and we're creating pods. How these two in sync with these labels only. The label has to be same. It should not be different. So yeah, spec, this is fine. Done. This is done. Toleration, it's not required. Continue this. For now. Containers, okay, I defined 2 containers. The only extra thing is we have to define the volume. How to define, let's try. Where is the spec? Let's from here on volume line templates. Sorry. Meta data some name something. Let's say DB data. Something as an example. Now we define the spec. Sorry. Spec. This spec is for volume. Access modes. I mean, I haven't told any of these. I haven't gone that far, but think access mode as like we're giving access to write to volume, the storage around. This is fine. Resources. I don't think this will work, but because we don't have any of this, but let's try. Request Hopefully it should work. Valid YAML. Now let's copy this. That's done. The only difference is here. All are same, right? I mean, we have seen all of these except this volume claim templates. Why this is required? Because I told you, right? Here, the volume claim templates, that means this, sorry, the stateful set, each and every pod, it have its own volume. I'm telling you, right? So the data will be stored persistently, even when a pod is rescheduled. That's why we have to define this. Only for stateful set, this will come. Volume claim templates for storage because of the unique storage the stateful set provides us. So far, let's create that. Awesome, awesome, man. Yes, so far I have to increase the timeout, but that's okay. Let's create a file accessing stateful set, obviously. Paste maybe stateful file. Let's try to create html apply hyphen f. This is dot error. All control characters are not allowed. Somewhere I am wrong. Which line did that show you? So volume, I believe this is the error. Name, blah, blah, blah. Spec, blah, blah. I'm just trying to do this. Maybe this spaces might have gone too far. Oh wait, why this happens here? Paste it yourself. If you,
I guess volume claim templates should
volume
come
claim
inside
template.
spec.
Oh, it should be inside spec. Got it, got it. Good. I completely forgot about it. So how it should be like, let me show you. Yeah, I think this is the template. How this should be like is, it should be fine. Let's try this. If it is not working, we'll change the template. Let's try this. Yeah, okay, created. Let's try version apps. Okay. When you create a stateful set in version can be defined as stateful set unknown volume plan templates. Apps v1. Okay, this is cool. Yeah, I think it should be inside, correct? It should be outside only. Wait. Kind stateful set. Let's copy from here. Why no bother about? Why we need to bother ML syntax? We have so many things. If you understand the concept, I mean, these ML files are available everywhere. So we simply copy from there. This is service. This is stateful set. See, this is now. Let's copy it somewhere. Paste it here. We don't need this thing. Yes, remove. He's trying to run the Nginx. Remove blah blah. The same thing. Metadata obviously, that's for service name Nginx. Replicas 14. No. 2 is fine for me. Containers blah blah. These things. We have to mount it. I forgot. So this is the volume claim template. Where is this? Is it inside spec? Yes, it is inside spec. Yes, it is inside spec. I missed it. That's okay. So volume claim templates we are using, the name is www. Access modes storage class is not required because we don't have this. So this is the right way. This is the one right we have written. And we are using this volume, whatever the volume we are creating, and we're mounting here. Just like we are mounting the volumes on Linux, you remember. Same thing. I told you, right? For now, just blindly, use this. Blindly, remember that we are creating a volume for stateful set, and we are using the volume. We are mounting the volume. Just remember that because it's a separate topic. We're just creating a volume and we are using the volume. And what happens now, since we are creating two pods, we'll have two volumes and it will be mounted in each and every pod, obviously. Now let's copy this. Let's go. Anything, I mean, you can use Nginx also as an example. There is no issues. Let's try. See, it's created. Don't waste time in, the syntax. Test deploy. Okay, it's still running. Let's remove. If you don't know the syntax is wrong, figure out, take an example from, Google and just try it. Change according to your scenario. Don't waste time. It's pending currently. Why it is pending? Let's see. Describe it. Describe anything if you want to know about it more. Web 0. See? Sorry. It's not some random name. It's 0. Next will be 1. I know it won't work because the pod, we need to create a volume, then only it will work. There is no volume. It's obvious. We have to set this volume, then only it will work. Let's create or has a monitor industrial volumes. Yeah, let me create that also. Let me create that. Let's give me a minute. I thought not to discuss this topic today, but yeah, we have to do it. Sorry. Forget about all what I'm writing. I'm just creating a volume. That's it. In Kubernetes, we haven't discussed that yet. But to finish this topic, I need this. Sorry. We'll discuss all of this in class. I'm just creating a volume. I'll explain you when the time comes. For now, just imagine that I'm just creating a volume with 1 GB size. That's it. Let me try. Okay, please move. Kind not set. What is this? Oh, wait. Error validating here, validating at a time not set. What is this time? Why did not set? API version capital V app slash. Sorry, it's V1 only, not PRFSC and the persistent. Okay. Metadata name, spec storage class name, capacity, storage access modes, host path. These are all fine. It should create. Creating validating data. What is the data? It's already nothing. Let me try this. Oh. The capital letter. This is how it adopts it sometimes. So now volume is created. Now I'll use the same thing. So what I'm just did it so far. Let me write this first. Okay, what other fields and replicas are there? So should be forbidden update should be equal to okay, volume claim templates. Am I correct? Yes. Metadata is name, blah blah blah. Spec, read write once, resources, request, storage class name. Did I miss something? It is storage class name. Spelling is correct. Template spelling, yeah, correct. It should be correct then. Let's see what is there. The stateful setup is invalid. Invalid spec. Forbidden updates to this is our invalid field. What is the field which we have used wrongly? Replicas, selector match labels, app, okay, templates, template yes, metadata, spec containers, blah blah blah. Ports, yes. Volumes, volume class, same thing. Let's figure out this error where we have entered this. Something is expecting. Wait. That's not an error. Now it will create this. See what the error is. I have updated. It's already running, right? The StatefulSet. I have updated some volume. I updated this thing, volume claim template. But we are not allowed to update it once it is created already. Only while creating a new one, it should be done. Pending still. Obviously, it will be pending. Storage class name. PV local name. Okay. Storage class manual. Storage class we did not took it. Okay, it's not took. Let me check it once. QCTL delete message part. Yes. Now open this SS dot again. Mhm. Notice let's play non capacity in the office until breadcrumbs. With TV available is close manual. Now I'll explain all these things. Don't worry what I'm trying to do. The volume is not creating. So why? I mean I create the volume. There is one more thing which we'll be using generally that is not working. That I'm seeing resources thickness storage class. Is it small letter or capital letter? No, it is capital. It should work. Simple level. Where we are missing? Okay. Yes, that's correct. I found an error. I don't know what is the error. What you do? Simply describe. No storage class. We have set the storage class. Obviously, it's not taking. MANUAL. That's correct. I have to check the spelling first. MANUAL. This is also correct. Uh, Checking 1 minute. Not there. Definitely some mismatch configurations happen over there. Mhm. Yes. Let's run. Okay, let's run. Let's try this. Container creating. Bound. These are pending. Okay. These also will come. Don't worry. It will take some time. It's running. This will also create. So yeah, what I did so far is I told you right. Stateful set will have its own unique state. Correct? That's what I told. So in order to have that, we need to create a volume first, so that that volume will be used in stateful set. I didn't have the volume earlier, when we were trying out stateful set, so that's why it was pending. And after creating volume also, it was pending because the names I gave were wrong. For volume, I gave one name, and while using the volume, I gave some different name. So that's what usually happens. That's what it happened. So that's why it took some time. Now, if you observe here, of course, these are on pending state. It will take time. Don't worry. But if you observe this one, sorry, this one, the names. See the names. These are unique, right? See the names here. Web 0, Web 1. These are unique. I told you, right? It will usually come in a sequential manner, 0, 1, 2, 3, like that. Even if you delete also, it will be in a sequential manner. Let's delete this one, Web 0 maybe. ctl delete pod / Web 0. Let's try. Yeah, it's deleted. Let's see. See, it's created. It will make sure that the number, the sequence, the unique numbers will be present. The sequences will be present. That's how. That's how usually will be created. But why, when, as I mentioned, it will take time. The pending will take time, not it will work. So when to use this stateful set? When we have these similar kind of scenarios where you want to store the session data. When you have similar, when you have applications like where it's required to store the session data, session information. What does, if you ask what information that session have? When you open a request, it will have where the request is coming from, what is the IP address, client IP, your browser details, which version of your browser you're using. Everything will be there in that information. They'll use it to give you, to analyze the data and provide the users a better experience. That's what they'll be using. So that's most applications use it. Some applications use, some don't. It depends on based on the requirement. So if you have this kind of stateful application, use stateful set. What are the advantages of this? First thing, it will be useful for stateful applications which store the session data. And another thing is each and every part what we are creating will have its own unique volume. It won't share the volume with other parts. Let's say I created two parts. It won't share the data between two parts. It will have unique volume. And another thing is the numbers also. The way it creates the pods also will be sequential manner. 0, 1, 2, 3, 4 like that. The names also will be like that obviously. The creation also will be like that. 0, 1, 2, 3 like that. Scaling down also will be like that only. First we delete 0, 1, 2, 3 like this. Now deleting reverse 5, 4, 3, 2, 1, 0 like this. So that's how it will create. Because why like that? Why other things are created randomly why this stateful set like this is because of the unique volume. Each and everything have its own unique state. I mean, each and every pod it has its own unique state, right? That's what I told. So due to that, the scaling is not easier. We it cannot scale randomly, just like other deployments or replica sets controller like these. It cannot scale randomly. It has to do the sequential order. So due to that, the scaling is little difficult because of the sequential manner it will follow. That's what about the stateful set. So we have discussed two things today: DaemonSet and stateful set. Any doubts so far? Of course, the in between we have an issue with volume. Volume is completely separate topic. Will come slowly next week somewhere in between. Okay. Before that, we have multiple topics to discuss. But as of now, these are the ways to create pods. I mean, to deploy applications in the cluster. Got it? Most commonly used, obviously, this is the one. Sometimes we use this also because I told you that the agents, we have monitoring agents, logging agents running. So we'll use DaemonSet to use this. Of course, this deployment uses internally stateful set only. These not recently anymore, and directly we don't create a pod. There is no use of creating a standalone pod. No scaling, no nothing will be there. If you delete the pod with manually, it will delete because there is nothing. These things will make the desired state. Mostly I've used these two things so far. Stateful set very rarely, one or two times mostly, because we don't use databases in. I mean, we're not using. We don't use. We're not using the databases in Kubernetes. We have outside. That's okay. So these are all the ways to create the pods. Next class we'll see how to access the application which is running inside the pod. We haven't seen that. Of course, when we run a container Docker run something, we access it in the browser, the IP address and the port number. But how to access here? That we'll see. So, if you are free, everyone tomorrow, we can continue the class. Same time, 6 p.m., 6:30 p.m. Let's say not 6. We might be sleeping, after having lunch. But is it okay at 6:30 or 7 o'clock tomorrow? I know it's Sunday tomorrow, but we can finish early. Otherwise, it will
okay.
take year end to close the topic. Everyone, I mean, just say everyone. Is it okay for you all? What time?
I'm traveling tomorrow, bro.
Oh, evening
By
5. You have
evening
to have
5
early.
p.m. is my bus.
Morning I can't have, so that's a difficult thing. We'll do one thing. I'll be doing lunch by 3 o'clock. It will take time. Maybe let's have it 4. Is it okay for everyone? Oh, 5 again. It's difficult. Let's try maybe. Let's do one thing. Try to, watch the video. We'll have a class at 7 o'clock maybe tomorrow. Yeah, try to connect from mobile at
Okay,
least.
okay, bro. I'll connect from
So
mobile.
for others, it's okay. Is it okay at 7 o'clock? Others? There are still people like this.
Yeah,
They're not
okay.
saying anything. Yeah. So let's
Fine,
have class
sir.
tomorrow. We'll try to utilize Sundays also. I know,
Okay, no.
but you have to make sure you get time to practice because we're getting really late. By we should not extend this thing by next year. So I want to close because we have AWS also, multiple tools also there. But we'll try to cover that. I mean, I don't rush the class. We'll skip the Sunday breaks. That's it. That's the one thing. I don't rush the topics and everything. That's fine. Okay. Tomorrow, 7 o'clock, we'll meet. We'll discuss how to access the pods. What we so far we have seen how create it, how they are running and everything. We'll see how to access them. Okay. Any doubts so far in today's class? Anything? Yeah. To practice.
No,
And yeah.
not now.
So yeah. Have a nice day. Bye.